Okay, this problem here looks relatively simple, but it can actually be pretty challenging. There are no triangles in it right now, so we have to create the triangles. And the only way this can be cut is like this. The reason we have to cut it that way is this is the only angle we know, the 72 degrees. And if we cut it the other way, we split up that angle and we don't know any angles. So knowing that one angle is a good start for us. From that, we can find this side here. I'm going to call this side x. So x squared is equal to 59 squared plus 74 squared minus 2 times 59 times 74 times the cosine of 72 degrees. Where did that mess come from? Law of cosines. Well, because I don't have any sides in their opposite angle, I have two sides and the angle in between them. So that comes to law of cosines. So that's going to give me x squared. And just like I did yesterday, what I'm going to do is I'm going to cross out that squared. I'm going to put a square root over here so I can type it in my calculator. So I'm going to do second square root, 59 squared plus 74 squared minus 2 times 59 times 74 times the cosine of 72 degrees. 79.11 millimeters. At this point, believe it or not, we have all the information we need to find the area. And remember, back last semester, we talked about something called Hero's formula. If we have all three sides of a triangle, we can find its area by using the perimeter and then the length of each side. So let's start off with this triangle over here. Its perimeter, 59 plus 74 plus 79.11. That's going to add up to what? 212.11. What's our next step in Hero's formula? What's S stand for? Semi-perimeter. So semi-perimeter, perimeter over 2. That's a good try. So we divide by 2. 106.055 millimeters. So then the area is the square root of that semi-perimeter, 106.055, times that semi-perimeter minus the first side, 59, times that semi-perimeter minus the second side, the 74, times that semi-perimeter minus the third side, the 79.11. We get 2,076.13. Does that look right?
Can you write out just Hero's formula?
Just Hero's formula? Yeah, Hero's formula here. Now it's the semi-perimeter. So the area for Hero's formula is the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. And now we got to do the same thing for the other triangle. That other triangle has sides of 61, 67, and 79.1. So that adds up to a perimeter of 207.11, which gives us a semi-perimeter. We divide that by 2 of 103.555. So the area, 103.555 times 103.555 minus 61 times 103.555 minus 67 times 103.555 minus 79.11. $1984.40. So we have to add those two together. 2076.13, 1984.40. $4,060.53 millimeters squared, or 40.6053 centimeters squared, or 0.004 meters squared. We'll most likely leave it as the millimeters squared. Now this problem has an interesting little effect in it. It kind of leads us into our new material for today. We're still dealing with law of cosines here. But we have a triangle here where we have all three sides and no angles. Now, if we have an angle and the two sides, just like we would use for law of cosines, we can actually find the area of a triangle. This first triangle here, down here, I could have found the area of that without finding the third side. I needed the third side, though, for the other triangle, but I can find that area based off of the two sides and the angle. This was 72 degrees here. This is 59 millimeters and 74 millimeters. To find the area of a triangle, I need base times height divided by 2, right? Well, the base is just the 74. The height here, if I draw that in, it forms a right triangle. To the 72, this would be the opposite side, and this would be the hypotenuse. So what I would have, sine of 72 degrees equals that opposite side over the hypotenuse. Well, we know that the hypotenuse is the 59. So here we would multiply 59 times the sine of 72. Cross multiplying, we divide by 1, but we don't have to divide by the 1. is going to equal that opposite side, which is our altitude. So the area of this triangle is just going to be 74 times 59 times the sine of 72 degrees over 2. In fact, there's an obscure formula for triangles that uses just that relationship there. Let's say I have angles A, B, and C. So this is side little a, little b, little c. The area of the triangle. I'm going to write out area instead of just A because I don't want to confuse it with angle A. Area is equal to side A times side B times the sine of angle C over 2. So I could have found this area up here very quickly by just doing that. 74 times 59 times the sine 72 divided by 2. 2076.16, just like we just had. A little different, a little bit of round off here is all. You have a question? Not need to know, but it's handy to know. So that gives us the area of this triangle right here. How about the one that I highlighted in yellow? Well, that one we have all 3 sides and no angles. And that's what we're going to look at working with right now. Sure. Got her? All right. I'm just going to put in numbers here. They're going to be easy for me to work with. Put in some sides there. I'll call my angles A, B, and C. I have all 3 sides. If you remember our formula for law of cosines, C squared equals A squared plus B squared minus 2AB cosine C. Now I could actually pick any angle that I want to, and I just have to readjust the formula. But you can see that involves all 3 sides. The only thing that's extra in there is one of the angles, which is good because we can use this to find the cosine of one of the angles. So we just have to pick which angle we want to find. Now, since the formula is set up with C there, it's easiest if we pick angle C. So I am going to pick angle C to solve for. So what goes first then? If this is my angle here, angle C. The 25 squared, that is C squared. Then of course it'll be A squared, which is 30 squared, plus B squared will be 20 squared, minus 2 times 30 would be next. 2 times A, then times B, times the cosine of angle C. So right now, this here, cosine of angle C is what I am solving for. So I'm going to simplify everything else here quick. 25 squared is 625. 300 squared is 900. 20 squared is 400. 2 times 30 times 60 is 1200, or 2 times 30 times 20, I should say, is 1200. Now here's where I have to be careful. I can combine those and get 1300. I cannot combine the 1200 with it because the 1200 is multiplying the cosine of C. that make sense? Order of operations, exactly. So now we have to solve this equation by subtracting 1,300. And yes, it's going to be quite common to end up with a negative over here. This is going to be negative 675. Over here, this is a negative 1,200 times cosine C. It is going to be pretty common to get a negative here because we're going to divide, in our next step, we're going to divide by a negative. It's going to be negative 1,200 we're going to divide by. So that's gone. I'm going to have to use the calculator to do negative 675 divided by negative 1,200. Now you notice I didn't put in the negatives, but a negative divided by a negative makes positive. So 0.5625. So the cosine of C equals that. So my next step is going to be to do inverse cosine. So second cosine of that answer is 55.77 degrees. Equals angle C. So once I know that angle C is 55.77, I can now use law of sines because I have an opposite side and a side in its opposite angle. The 25 over the sine of 57 or 55.77. Now, we mentioned this a little bit in over the last couple of classes. Which side do I want to use first, the 20 or the 30? The smaller one, the 20. Great. Because the larger side could potentially be opposite of an obtuse angle, and we don't really have any way of telling for sure. This picture makes it look like it's pretty surely acute, but we can't be sure. It's easier if we go after the smaller angle and subtract from 180 to get the larger one. So this is going to be sine of B down here. So now we will cross multiply and divide. So sine of 55.77 times 20 divided by 25. Gives us 0.6614. So the sine of B is 0.6614. So B will be the inverse sine of 0.6614. Which gives us 41.41. We combine that with the 55.77. $97.18 from 180. 82.82 degrees is the final angle. Which could have been kind of difficult to figure out if we'd have just gone for it right away.
Which ones were we given?
You were given the three sides. From the three sides, remember, we used the law of cosines here to find this angle. So looking at this one here, I'm going to have you guys talk me through finding the angles. Tell me where to start. Want to find angle C first? That's good. Okay. Okay. Cosine of angle C. Perfect. Then we solve it. Now, I'm going to show you, since we're going to be doing this over and over again, let's take a step back here. Well, still, if I want to know angles A and B as well, though, it doesn't give you angles A and B. So, if I was solving this for cosine C, I would have to subtract A squared and B squared, right? I'd subtract A squared and B squared from both sides. So I have C squared minus A squared minus B squared equals negative 2AB cosine C. And then you had it, Spencer. What's the next step? Negative 2AB. So what this is giving us is the cosine of C is equal to C squared minus A squared minus B squared over negative 2 times A times B. So that shortens it up a little bit for us. So we can actually just put this in the calculator. We know that C is 14, so 14 squared minus A is 27, so 27 squared minus B is 36, so 36 squared. We do have to hit equals at this point. And then you're going to divide by, you're going to put these in parentheses, negative 2 times A is 27 times B is 36, and close that parentheses. Oh, what you saying? Oh, I used a minus instead of a negative. Now it'll work. So I get 0.9408 equals the cosine of C. So now all I have to do is inverse cosine. Second cosine, second answer. 19.81 degrees equals angle C. And from this point, I trust you guys can find angles A and B. The only thing I will note, just because I really want to drive it home, we'll use the 14 over the sine of 19.81 degrees. Which side would we use next? It's 27, the smaller one. What's that? You always want to use the smallest one because we don't know if this angle, since this is the largest side, there's a chance that its opposite angle is obtuse. And in this case, I believe it is obtuse. But when you do the law of sines, you don't know that for sure, because the law of sines gives you two possible answers. So you know that the only angle that can be obtuse is the biggest one. So you know B is the only possible obtuse angle. So since you know A has to be acute, this one's going to be easier to solve because you know that what you get is going to be the right answer for A. You don't have to worry about whether it's a supplement or not. Let's just do it since we've got it up here. So sine of 19.81 times 27 divided by 14. We get 0.6536 for the sine, so we're going to inverse sine. We get that A is 40.81. And then we would combine the 40.81 and the 19.81. Which is going to give us, what, 60.62? Subtract that from 180 is 119.38. So that does come out to be an obtuse angle up there. What do you think? I'm going to have you guys try one.
That was you.
Find angle C for me. So let's see here. We've got 37 squared minus 18 squared minus 41 squared over negative 2 times 18 times 41 equals the cosine of C. So 37 squared minus 18 squared minus 41 squared divided by, parentheses, negative 2 times 18 times 41 is 0.4309, 0.430, equals cosine C. So we do an inverse cosine. $64.48 I get. So on that note, we had given you page 382 to 385 yesterday in the packet. There were a few problems in there that had all three sides and none of the angles. Now you should be able to go back and finish those off. Tomorrow there will be a quiz on laws of sines and cosines. Then we'll be doing some review, and then Thursday is our unit test. We'll wrap up the unit.
What's all on the unit test?
Trig, all the trig identities and all that stuff. We'll do a little bit of review tomorrow. But the biggest one people get stumped on is stuff like this. A plus B equals 90 means A and B are complements. So if the sine of A equals 0.4, what's the cosine of B? 0.4. If they're complements, the sine of one equals the cosine of the other. And yes, we will go over that stuff tomorrow. So I'll make sure you have finished off page 382 to 385 for tomorrow.